Hello, and welcome to this film, which is about writing balanced redox equations. And we're going to be doing this using the half equations that we learned to write in the previous film. If you don't know how to do those yet, I'm going to be going through that really quite fast in this film, so it'd be a good idea if you went back and watched that film. Okay? But what we're going to be able to do, hopefully by the end of this film, is we're going to look at oxidation and reduction processes, and we're going to make sure that the number of electrons in those is the same. Okay, and then we're going to write balanced overall redox equations by combining half equations, right? And we're going to do this in two different ways. We're going to look at the names of the substances that are the reactants and products, and we're also going to do it by looking at the observations of a chemical reaction and seeing if that tells us what we're making. Okay, so let's have a look at some examples, but before we do, here's a sequence of rules again that you might choose to follow. Numbers 1 and 2 here kind of joint first. It doesn't matter which one of these two you do first, but you're going to write a half equation for the oxidation and a half equation for the reduction. You're then going to balance the electrons by multiplying one of the equations or both, and then you're going to combine the half equations and cancel out the electrons. Now, as usual, these rules can seem a little bit obscure without an application for them, so here's an example. Okay, chlorine water is bubbled through potassium iodide. What have we got here to begin with? Well, we've got chlorine molecules, and we've got iodide ions, and we've got potassium ions as well, but they're not changing, so I'm not going to write any half equations for them. What are we making? Well, we're making chloride ions, okay, and we're making iodine, right? Balancing the atoms, 2 and 2. Balancing the charges, 2 electrons, 2 electrons. So that's writing half equations like we did in the last film. Here's our reduction, here's our oxidation. We're just checking now that the number of electrons that the reduction needs is the same as the number of electrons that the oxidation gives up. Yes, they're the same. So now all I have to do is combine all my reactants together and all my products together. But remembering that if I've done this correctly, my electrons are going to cancel out. Okay, so 2Cl minus plus I2 and 2 electrons as our products. Right, so that's all the things on the right. All the things on the left are over here on the left, and rightly so, the electrons cancel out. So I'm left with this overall balanced equation. I can rewrite it if I want without the electrons in it at all, but there's no need to do that if I've crossed them. Okay, so there we go. That's how it's done. That's me following those rules. Let's have another example. This is a little bit more complex because the number of electrons isn't going to be the same this time. So anyway, let's think about what we've got to begin with. We've got aluminium and we've got hydrochloric acid, so that's got H plus ions and Cl minus ions. The chloride ions aren't changing, so I'm not going to write an equation for them. So I'm going to write an equation for the H plus ions that I'm starting with. What am I forming? Aluminium chloride's got Al3 plus ions, and hydrogen has the formula H2. Okay, so I need 2 H plus ions. That means I'm going to need 2 electrons there, and I need 3 electrons here. Now this time, as I said, the number of electrons isn't the same, so I've got to do something about that. How can I make them the same? Well, I could multiply this equation by 2 and this one by 3. Okay, and now when I combine these two equations, I should have 6 electrons in both of them. But I need to remember to multiply everything in them by these numbers. So here we go, 2 aluminiums and 6 H pluses, and these 6 electrons, which I know are going to cancel, so I'm not going to include them, is going to make 2 aluminium 3 plus ions and 3 of these hydrogen molecules. Okay, so again, there's an overall balanced redox, Al3 plus, overall balanced redox equation from my 2 half equations. But this time I had to multiply the equations to make sure that the number of electrons was the same. Now, these next 2 examples are basically the same principles involved, but instead of being told what we're starting and finishing with, we're being told what we start with and what it ends up looking like. So we're going to have to do a little bit of detective work and figure out what we've got at the end. We're starting with zinc here. So zinc is one of my starting materials. It's placed in copper nitrate. So we've got copper ions here and nitrate ions. Which one of those is going to react? Well, the clue is here. We're forming a brown solid, or even more of a clue, it's salmon pink. It would look brown, but your datasheet describes it as salmon pink because fresh copper is salmon pink. So the clue here is telling us that copper's forming from copper ions. So it must be the copper ions in one of the half equations forming copper, okay, and that requires 2 electrons. Okay, the solution's going from blue to colourless. So whatever ion is forming is a colourless ion, and zinc ions are colourless, right? So they're going to turn into zinc 2+, and that requires 2 electrons too. So once again, our electrons balance. So I just put all my reactants together on one side of my equation, zinc and copper 2+, make copper and zinc 2. Overall balanced redox equation using the half equations, but this time trying to decide what the products are from the observations that we're given. Okay, this is actually a metal displacement reaction. Okay, and we'll see a real life example of this in one of the next few films, which is basically based on the practical side of this, so we'll see these reactions actually happening. Okay, last example for this film. Sodium bromide is shaken with chlorine water, resulting in the formation of a brown solution. So again, some detective work going on here. I'm starting with bromide ions, forming a brown solution. Well, if I look on my datasheet, I'll see that bromide ions will form bromine water, which is brown. Okay, so by looking at this brown colour here, I can tell that the bromide has turned into bromine. I need 2 bromine ions for that. Okay, what else is going on? Well, perhaps the sodium ions are gaining these electrons. But if they were going to do that, if they were going to gain electrons from bromide, they'd have done it before I even added the chlorine. So that's not likely. So it must be the chlorine that's reacting. Okay, and what's chlorine going to form if it gains these electrons? Well, it's going to form chloride ions. Okay, it's going to form 2 of them because chlorine is made of 2 atoms. And I need 2 electrons to make that change happen. So there's the oxidation, there's the reduction, both with 2 electrons in. Combine the oxidation and the reduction together, and I'm left with 2 bromide ions reacting with chlorine water, producing 2 chloride ions and bromine. And that's an example of halogen displacement, which is also going to be on one of the next few films as a practical demonstration. Hopefully that all makes sense. If it doesn't, then as usual, come and ask some questions or post a comment on YouTube and I'll see if I can answer your question on there. Likewise, if I've made any mistakes, I'd really appreciate you letting me know so that we can correct those on the film.